Hello class, this is Mr. Lehman. Today I want to talk to you about lesson 2 in the Toxins unit. It's all about predicting change, observing changes. And what I have here, I have 4 equations that we're going to take a look at and try to predict what's going to happen. And then we'll take a look at the chemical or physical change, which is also something we're going to talk about in the next section in lesson 3. Alright, so here we have NaCl. NaCl is sodium fluoride, table salt. It's table salt in a solid form. And so it's going to go from a solid form and it's going to turn into the aqueous form. So what happens when something turns from a solid to aqueous? It means that we dissolved it. We dissolved it in water. So if something goes from a solid form to the aqueous form, it means that it is now dissolved in water. So we mix it with water, we stir it up. We don't have to write the water part of it. But just by putting the HU, that means dissolved in water. So we know the water's there. We know it's broken down in the tiny, tiny ions within that water. So simply sodium fluoride that has been dissolved. Now what happens, this is, let's say, equation 1b. What happens here if we have our dissolved sodium fluoride, or aqueous sodium fluoride? But what happens, what would have to happen in order for it to turn back into a solid? Well, we would have to get rid of the water. So what do we do to get rid of the water? We could evaporate it, or we could boil it off. And so if we get rid of the water, salt will form again. And so because of this, because we can get the salt back in the original form, and it's really there all along in the water, we say that dissolving is simply a physical change. All right, let's take a look at a couple more. Equation 2 here. What about if we have table salt in a solid form and it turns into table salt in the liquid form? What happened here? It's not dissolving anymore. There's no water. We simply have it melting. And so melting is a phase change, and phase changes is an example of a physical change as well. Because we have the same chemical, NaCl, it just changes form. It changes from a solid to a liquid. Equation number 3. This is the formula for sucrose, which is commonly called table sugar. This is what we add to our coffee. So we have solid sugar, white sugar, and it's going to produce 12 carbons in a solid form, plus 11 waters in a gas form. So it's no longer sugar anymore, it's splitting apart, and so because it's splitting apart, we're getting some water vapor forming. This is going to be a chemical change. This is what happens when you heat up sugar. It'll actually start to break down and decompose. So because we're producing new chemicals, new chemical formulas, this is a chemical change. Let's do one more here. Would this be a physical or chemical change? Hopefully you said chemical. Chemical change is correct. The reason why it's a chemical change is because we're producing new chemicals. We start out with magnesium by itself. Magnesium comes in and it links up with the chlorine during a chemical reaction while it's taking place. This magnesium fluoride will be dissolved in water. And then the hydrogen, which gets booted out, the hydrogen is now by itself, and it's going to form little bubbles of gas. So while this reaction is taking place, we'll see gas bubbles, we'll see some fizzing, and we're going to have a solid dissolving. The magnesium will be disappearing and it'll be dissolving into the solution, combining with the chlorine and dissolving in water. Alright, so that was lesson 2 for you. Hopefully this helped. Have a great day.